There is a fact about heat that every person understands instinctively and almost no one thinks about deliberately. Heat rises. Warm air is lighter than cold air, so it floats upward. Through the room, past your face, past the ceiling, and out through every crack and gap in the roof, carrying the warmth you paid for in firewood, and labor out into the sky where it does nobody any good. This is why a cabin heated by a fireplace or a stove is always warm near the ceiling and cold near the floor. The heat source is at waist height or above. The warm air rises immediately, and the coldest air in the room, the air that has given up its heat to the walls and the windows and the gaps in the chinking, settles to the floor where your feet are. You can stand next to a roaring fireplace and feel sweat on your forehead while your feet, 6 feet away on the plank floor, are numb with cold. You can burn 5 cords of wood in a winter and still wake every morning to a cabin where the floor is so cold it hurts to step on it with bare feet. This is not a flaw in the fireplace. The fireplace is doing exactly what physics requires it to do, heating the air, which rises, which escapes, which must be replaced by more heated air, which requires more fuel, which rises, which escapes. The cycle is wasteful by design. A fireplace converts wood to heat with an efficiency of approximately 10 to 15%. A cast iron stove does better, perhaps 30 to 40%, but even a good stove heats the air, and the air rises, and the floor stays cold. The problem is not the fire. The problem is the delivery method. Heat delivered to the air is heat that rises and leaves. Heat delivered to a solid mass, stone, brick, earth, clay, stays where you put it. In the villages of the eastern Caucasus, in the region that is now Azerbaijan, the winters are not as long as Montana's, but they are bitter. The wind comes down off the high plateaus at 4,000 feet and cuts through the valleys like a blade, and the temperature drops to 0 or below for weeks at a time. The people of the Caucasus had been dealing with cold for as long as anyone had been living there, and they had arrived at a solution that was fundamentally different from the European approach of heating the air with an open fire. They heated the ground. The traditional Azerbaijani heating system was called a kürsü in its simplest form. A low table placed over a pit of hot coals, covered with a thick blanket, around which the family sat with their legs under the blanket, absorbing the radiant heat of the coals through the earth and through their bodies. But the kürsü was a personal heating device, not a whole house system. The whole house version was more ambitious. It was a raised stone floor built over a network of channels through which hot air and smoke from a fire were directed before exiting through a chimney at the far end of the building. The fire heated the stones. The stones stored the heat. The heat radiated upward through the floor into the living space above, slowly, steadily, evenly, for hours after the fire had gone out, because stone holds heat the way a bucket holds water. You fill it once, and it gives it back gradually. The larger the mass of stone, the more heat it stores, and the longer it radiates. A floor built on a bed of heated stone 3 feet thick would stay warm for 12 hours after the fire was extinguished. A floor built on a bed 6 inches thick would stay warm for 3 or 4 hours. The thickness of the stone bed determined the duration of the heating cycle, and the size and intensity of the fire determined the peak temperature. This principle, heating a thermal mass and letting it radiate, is the same principle behind the Korean ondol, the Roman hypocaust, the Chinese kang, and the Afghan takana. Every cold climate civilization that built with stone or earth eventually discovered it, because the physics is universal and the observation is obvious to anyone who has ever sat on a sun-warmed rock in the evening, and felt it give back the day's heat long after the sun went down. The Azerbaijani version was distinguished by its integration with the tandir, the cylindrical clay oven that was the center of the household kitchen. The tandir was not just a bread oven. It was the heat source for the entire floor system. The fire that baked the bread also heated the stones that warmed the house. One fire, two functions, zero waste. Now, Togrul Karimov did not arrive in Montana intending to build an Azerbaijani heated floor. He arrived in Montana intending to survive, which is a different ambition entirely, and the floor was a consequence of survival rather than a plan. Togrul had left Baku in 1882 at the age of 27, following the trail of the petroleum industry that was drawing workers from across the Caucasus and beyond to the oil fields of Pennsylvania, and later to the railroad construction camps of the American West. He was a trained blacksmith. He had apprenticed in his uncle's forge in the village of Lahıc, in the mountains south of Baku, a village famous across the Caucasus for its coppersmiths and metal workers, where every boy learned to work metal before he learned to read. The skills that made a good blacksmith, the ability to judge temperature by color, to understand how metal moves under stress, to build and maintain a forge, to work stone and brick and clay as well as iron, were exactly the skills that the railroad construction companies needed, and Togrul found steady work in the rail camps moving westward across the northern plains. He worked the Northern Pacific Line through Dakota Territory and into Montana, setting up temporary forges at each construction camp, sharpening drill bits and repairing tools and shoeing horses and doing the 100 small metalwork jobs that a railroad construction crew generated every day. The work was hard, but the pay was better than anything available in Lahıc, and Togrul saved methodically. He did not drink, he did not gamble, he ate cheaply, and he sent half his wages back to Baku, where Aysel was waiting with their two young children, Farid and Sevda. By 1888, the Northern Pacific was complete through Montana, and the construction work had dried up, but Togrul had saved enough to file a homestead claim on 160 acres in the Bitterroot Valley, and to send for Aysel and the children. They arrived in the fall of 1888, Aysel carrying everything the family owned in 2 trunks and a carpet bag, Farid 9 years old and Sevda 7, all of them stunned by the scale of the landscape, the width of the valley, the height of the mountains, the emptiness of the sky. The Bitterroot Valley was beautiful and enormous and exposed. There was nowhere to hide from the wind. The first winter, 1888 to 89, nearly killed them. Togrul had built a cabin in the standard Montana fashion, a timber frame box with rough sawn plank walls, a stone and mortar chimney, a cast iron stove purchased from the general store in Stevensville for $14, and a plank floor laid directly on log joists resting on the ground. The cabin was adequate shelter by Montana standards. Every cabin in the valley was built the same way, and every family in the valley endured the same winter experience. The stove burned hot. The air near the stove was warm. The air 6 feet from the stove was cool. The air at the far wall was cold, and the floor was freezing. The children slept in wool socks and double blankets and still woke with cold feet. Aysel cooked in sheepskin slippers because standing on the plank floor in bare feet was painful after 10 minutes. The wind found every gap in the plank walls and pushed cold air through the cabin at floor level. A constant river of freezing air that no amount of stove heat could overcome, because the warm air rose and the cold air stayed low, and the floor was a 40-degree slab of wood sitting on frozen ground. The temperature stratification inside the cabin was dramatic. Togrul hung a piece of wet cotton at ceiling height, and another at floor height on the same day in January. The one at ceiling height dried in 2 hours. The air up there was warm and dry, perhaps 70 degrees or more, heated by the rising column of air from the stove. The one at floor height was still damp 6 hours later. The air down there was cold and moist, perhaps 40 to 45 degrees, barely above the temperature at which breath becomes visible. The family lived in a cabin that was 2 different climates stacked on top of each other, summer at the ceiling and late autumn at the floor. And they lived at floor level because that was where the beds were, where the table was, where the children played, where Isel worked and cooked and sewed and did everything that a homestead wife did for 16 hours a day. The cold floor created problems beyond discomfort. Farid, who was 9, developed chilblains on his toes, painful red swellings caused by repeated exposure to cold that were not quite frostbite, but that itched and burned and cracked and bled and made walking painful for weeks. Sevda, who was 7, caught a chest cold in December that settled into a persistent cough that lasted until March. Isel's hands cracked and bled from the combination of cold and wet. She washed clothes and dishes in water heated on the stove, but the cold floor chilled her feet and lower legs continuously while she worked, and the temperature differential between her warm upper body and cold lower body stressed her circulation and dried her skin until it split. Togrul burned 7 cords of firewood that first winter. 7 cords was an enormous quantity. Each cord was a stack 4 feet wide, 4 feet tall, and 8 feet long, and 7 cords represented approximately 250 cubic feet of cut and split hardwood. At the going rate of $3 per cord, the firewood alone cost $21, more than the stove itself, and the cabin was still cold at floor level. The stove was doing its job. The heat was simply going to the wrong place. On the coldest night of that first winter, minus 26 degrees Fahrenheit on the 8th of February, Togrul lay awake on the plank floor under 3 blankets and a sheepskin and felt the cold radiating upward from the frozen ground, through the planks and through the sheepskin and through the blankets into his back and his legs and his feet, and he thought about his mother's house in Lahıc. He thought about the stone floor that was always warm in winter. He thought about the channels under the floor and the basalt that his father had hauled from the river and the firebox that his grandfather had built. He thought about walking barefoot across that floor on a January morning when the snow was 3 feet deep outside and the wind was howling through the mountain pass and the floor was warm and the warmth came from below, from the stones, from the earth, from the fire that had burned the evening before and gone out hours ago, but whose heat was still held in the rock like a memory that the stone refused to release. He decided that night that he would rebuild the floor. Not next year, not eventually. In the spring, as soon as the ground thawed enough to dig. The second spring, Togrul began to rebuild the floor. He did not explain what he was doing to anyone in the valley. His English was functional but limited. He could buy supplies, negotiate prices, and exchange basic pleasantries, but he could not explain the thermal physics of radiant stone heating to a Montana rancher in a way that would make sense, and he did not try. He simply began digging, but before he dug, he collected stones. For 3 weeks in April and May, while the ground was still too frozen in places to excavate the cabin floor, Togrul hauled basalt cobblestones from the riverbank. The Bitterroot River had, over thousands of years, deposited vast quantities of smooth, rounded basalt along its bends and gravel bars. Stones tumbled by water and ice until they were as smooth as polished eggs, ranging from the size of a man's fist to the size of a man's head, dense and dark gray and heavy in the hand. Togrul was particular about which stones he chose. He rejected any stone with visible cracks or fractures. A cracked stone would split when heated, and a splitting stone in a heating channel could block the airflow and create dangerous pressure pockets. He rejected stones that were too round. They would roll and shift in the channel, leaving gaps that reduced the thermal contact between stones. He preferred stones that were slightly flattened, egg-shaped or disc-shaped, with at least one flat face that would stack and nestle against its neighbors with maximum surface contact. Maximum surface contact meant maximum heat transfer, each stone touching its neighbors on as many surfaces as possible, so that the heat from the firebox would conduct from stone to stone through the entire channel bed like a wave moving through a crowd. He hauled the stones in his wheelbarrow, approximately 150 pounds per load, 6 loads per day for 3 weeks. The total weight of basalt cobblestones required for the 3 channels was approximately 9,700 pounds, nearly 5 tons of river stone, hauled 300 yards from the riverbank to the cabin, 1 wheelbarrow load at a time. Isel helped on the weekends, carrying stones in a canvas sack on her back, 30 to 40 pounds per trip, while Farid and Sevda carried the smaller fist-sized stones in buckets, 2 at a time, competing to see who could make more trips in an hour. He removed the plank floor and the log joists and dug out the interior of the cabin to a depth of 18 inches below the original ground level. This was hard work. The ground was rocky clay, packed tight, and every inch had to be loosened with a pickaxe and shoveled out by hand. The excavation produced approximately 400 cubic feet of spoil, which Togrul wheelbarrowed outside and used to build up a berm around the cabin foundation for additional wind protection and insulation. The excavation took 2 weeks, working every day from dawn until the light failed. In the excavated floor, Togrul dug 3 parallel trenches running the full length of the cabin from east to west. Each trench 12 inches wide, 12 inches deep, and 18 feet long, spaced approximately 3 feet apart, center to center. The trenches were the heating channels, the arteries through which hot air and smoke would flow from the firebox at the east end of the cabin to the chimney at the west end. He lined the bottom and sides of each trench with dry-stacked basalt cobblestones collected from the riverbank. Smooth, rounded stones ranging from the size of a fist to the size of a man's head, chosen for their density and their ability to absorb and hold heat. Basalt is an ideal thermal mass material. It is dense, approximately 180 pounds per cubic foot, and it has a high specific heat capacity, meaning it absorbs a large amount of thermal energy per unit of mass. A cubic foot of basalt, heated to 200 degrees Fahrenheit, stores approximately 3,000 British thermal units of energy and releases it slowly over 6 to 12 hours as it cools back to ambient temperature. The 3 trenches in Togrul's floor contained approximately 54 cubic feet of basalt cobblestones, enough thermal mass to store approximately 160,000 BTUs of heat, which was equivalent to the heat output of burning approximately 15 pounds of dry pine. At the east end of the cabin, where the stove had previously stood, Togrul built the firebox, a stone and clay combustion chamber approximately 2 feet wide, 2 feet tall, and 3 feet deep, set into the foundation wall at floor level. The firebox opened into the cabin through an iron door that Togrul forged himself from scrap railroad iron. A heavy hinged plate with an adjustable air vent at the bottom that controlled the rate of combustion by regulating the airflow into the fire. The back of the firebox connected to the 3 heating channels through a distribution chamber, a mortared stone box approximately 2 feet square that split the single stream of hot combustion gases from the firebox into 3 parallel streams, 1 for each channel. Togrul made clay damper plates for the distribution chamber, flat clay discs that could be rotated to partially or fully close any of the 3 channel openings, allowing him to direct more heat to one side of the cabin or the other, depending on need and wind direction. The hot gases from the firebox entered the distribution chamber, split into 3 streams, flowed through the stone-lined channels beneath the floor, heating the basalt cobblestones as they passed, and exited at the west end of the cabin into a vertical stone chimney that drew the cooled exhaust gases up and out of the building. The path of the gases from firebox to chimney was approximately 20 feet, long enough to extract the majority of the heat from the combustion gases before they exited the building. In a conventional stove, the combustion gases traveled approximately 3 to 4 feet from the firebox through the stovepipe to the chimney, and most of the heat went straight up the pipe and out the roof. Togrul's system extracted heat over 20 feet of channel length, giving the basalt stones 5 times as much contact with the hot gases and absorbing 5 times as much energy before the exhaust left the building. Over the 3 channels, Togrul laid flat flagstones, smooth level slabs of the same basalt that he had split with a hammer and cold chisel into pieces approximately 2 inches thick and 12 to 18 inches across. The flagstones were laid edge to edge with tight joints filled with sand and fine clay, creating a continuous stone floor surface that was smooth enough to walk on comfortably and thin enough to allow heat from the channels below to radiate through to the surface within an hour of lighting the fire. The total thickness of the floor assembly, from the bottom of the channels to the top of the flagstones, was approximately 14 inches. The flagstones added an additional 2 inches of thermal mass on top of the channel stones, bringing the total thermal mass of the floor to approximately 60 cubic feet of basalt, capable of storing nearly 200,000 BTUs of energy. Acel covered the flagstone floor with thick felt rugs made from wool she had carded and pressed herself. The same dense felt that Caucasus families had used as floor covering for centuries, 3/4 of an inch thick, warm under bare feet, even when the stone beneath was cool, and an excellent insulator that slowed the release of heat from the stone and extended the warming cycle. In the sleeping area, she laid double layers of felt with sheepskin over the top. The children would sleep directly on the warm floor, rolled in blankets, with the heat rising gently through the felt and the sheepskin into their bodies from below. If you want to know what happened when a Caucasus blacksmith buried hot stones under a Montana cabin floor, subscribe to this channel and tell me in the comments where you are watching from. The first test was in late October of 1889, when the nights were dropping into the 20s, but the deep cold had not yet arrived. Togrul built a fire in the firebox at 5 o'clock in the evening, a moderate fire of dry pine splits, approximately 20 pounds of wood, burned for 2 hours. He opened all 3 damper plates fully, allowing the hot gases to flow evenly through all 3 channels. Within 45 minutes, the flagstone floor nearest the firebox was warm to the touch. Within 90 minutes, the entire floor was warm. Not hot, warm. The surface temperature of the flagstone, measured by the only reliable method available to Togrul, which was placing his palm flat on the stone and judging the sensation, was approximately what he estimated to be 85 to 90 degrees. Warm enough to be pleasant under bare feet, not hot enough to be uncomfortable. Isel took off her shoes and walked across the floor in bare feet and stood in the center of the room and did not move for a long time. She was standing on a warm floor in Montana in October. With no fire burning, Togrul had let the fire die after 2 hours and the floor was still warm. She said nothing, but Togrul saw her expression and understood it because it was the same expression he had seen on his mother's face every winter in Lahıc when the floor was right and the heat came up through the stones and the cold outside could not reach you because the warmth was under your feet and in your bones, and it did not matter what the wind did to the walls. At 10 o'clock that night, 5 hours after the fire had been lit, 3 hours after it had gone out, the floor was still warm. Not as warm as it had been at the peak, but warm enough that the children fell asleep on the felt rugs without blankets and did not wake cold. At 6 o'clock the following morning, 13 hours after the fire had been lit, 11 hours after it had gone out, the floor was cool but not cold. The surface temperature was perhaps 60 degrees, well above the ambient air temperature, which was 34 degrees outside and approximately 45 degrees inside at ceiling level. The floor had held its heat for 11 hours after the fire went out. Togrul's mother's floor in Lahıc held its heat for 14 hours, but the Lahıc floor was built on a stone bed 3 feet thick, a massive thermal battery that took half a day to charge and half a day to discharge. Togrul's floor, with its 12-inch channels and 2-inch flagstone cap, was a lighter system with a shorter heating cycle, but it was sufficient for the Montana climate if the fire was lit twice a day, once in the early morning and once in the early evening, with each firing lasting approximately 2 hours. If this story has touched you, share it and subscribe, because the quiet engineering that kept families alive and farms running for generations deserves to be remembered. The deep cold came in December. On the 12th of December, the temperature dropped to -14 degrees Fahrenheit and stayed below zero for 6 consecutive days. The wind from the northwest was constant, not gusting, not variable, but a steady, relentless 15 to 20 mile per hour current of sub-zero air that flowed across the open valley floor and hit every cabin on the west side of the river with a force that pushed cold air through every gap, every crack, every imperfect joint in the walls. The cabins in the valley that were heated with stoves became, as they always did, furnaces at shoulder height and ice boxes at floor level. Nolan Pickerel, whose ranch was a quarter-mile south of the Karamov place, told Togrul afterward that his wife had worn 3 pairs of wool socks inside sheepskin moccasins for the entire 6 days and still complained of cold feet, and that their 2-year-old son had developed a persistent cough from sleeping on the cold plank floor, despite being wrapped in every blanket they owned. Pickerel himself slept in his boots, not because he was too tired to take them off, but because his feet went numb within minutes of removing them, and the numbness did not go away until he stood next to the stove for 10 minutes in the morning, and he had decided that sleeping in boots was less miserable than the morning ritual of thawing his feet. The problem was not that Pickerel's cabin was poorly built. It was built as well as any cabin in the valley. Tight joints, good chinking, a solid stove that drew well and burned clean. The problem was that the stove heated the air, The air rose, the heat went to the ceiling, and the floor remained at whatever temperature the frozen ground beneath it happened to be, which in a 6-day sub-zero cold snap was approximately 32 to 35 degrees Fahrenheit, cold enough to cause pain in bare feet within seconds and numbness within minutes. Every cabin in the valley had the same problem. Every family in the valley wore boots indoors. Every child in the valley slept in socks. This was considered normal. This was winter. In the Karimov cabin, the floor was warm. Togrul had adjusted his firing schedule for the deep cold. 3 firings per day instead of 2, each using approximately 25 pounds of dry pine, for a total daily wood consumption of approximately 75 pounds. 75 pounds of wood per day for a week was 525 pounds, or approximately a quarter cord. At the rate of $3 per cord, the fuel cost for heating during the worst week of winter was approximately 75 cents. By contrast, Pickerel's cast iron stove consumed approximately 40 pounds of wood per firing, fired 4 to 5 times per day in extreme cold, for a total daily consumption of 160 to 200 pounds, more than twice the Karimov system. Pickerel's weekly fuel cost during the cold snap was approximately $1.50, double the Karimov cost, and his floor was still cold. The reason for the efficiency difference was not that Togrul's fire was hotter or his wood better. It was that the Karimov system extracted heat from the combustion gases over a 20-foot path and stored it in 60 cubic feet of basalt, while Pickerel's stove extracted heat over a 3-foot path and stored it in approximately 2 cubic feet of cast iron. The basalt thermal mass was 30 times larger than the stove mass. It absorbed 30 times as much energy from each firing, and it released that energy downward, into the floor, into the living space where people actually spent their time, not upward into the ceiling and out through the roof. The floor temperature during the deep cold held steady at approximately 80 degrees at the surface nearest the firebox, and approximately 70 degrees at the surface farthest from the firebox, with a gentle gradient between the two that Togrul controlled by adjusting the damper plates, opening the channels nearest the far wall wider to push more hot gas to the coldest zone, and partially closing the channels nearest the firebox where the stone was already saturated with heat. This ability to zone the heating, to direct more warmth to specific areas of the floor, was something that no stove could do. A stove radiated heat in all directions equally, heating the air nearest to it and leaving the far corners cold. Togrul's system could be tuned like an instrument, directing heat where it was needed and conserving fuel where it was not. By mid-January, the valley had experienced 3 separate cold snaps: the 6-day event in December, a 4-day event in early January that reached -22, and a 3-day event in mid-January that reached -19. Through all 3 events, the Karimov floor system performed consistently. The children slept barefoot on the felt rugs. Isel cooked barefoot on the warm flagstone. Togrul walked barefoot through the cabin in the morning to light the fire, his feet on stone that was still 60 degrees from the previous evening's firing, while the air temperature outside was 20 below zero. Word of the warm floor spread through the valley the way information always spreads in a small frontier settlement. Slowly, through casual conversation, through the observations of visitors, through the complaints of wives who had visited the Karimov cabin and returned to their own cold floors with a new and specific dissatisfaction. Bertie Loomis, whose farm was on the north end of the valley, came to deliver eggs in February and stayed for 2 hours because the floor was so warm. She took off her boots and sat on the felt rug near the tander and drank tea and told Aysel that she had not felt her feet properly warm since October. She stretched her legs out on the felt and wiggled her toes and pressed her palms flat against the flagstone where the rug ended and said she could feel the heat coming up through the stone into her hands like touching a warm animal. She asked Aysel how it worked, and Aysel explained as best she could the channels, the stones, the firebox, and Bertie listened with the careful attention of a woman who had spent 4 winters with cold feet and who was hearing, for the first time, that cold feet were not an inevitable consequence of living in Montana, but a solvable problem. She went home and told her husband Calhoun that the Karimov cabin had a heated floor, and that it was the most comfortable room she had been in since leaving Virginia, and Calhoun told Pickerel, and Pickerel told the men at the general store. And within a week, everyone in the valley knew that the Azerbaijani blacksmith had done something to his floor that made it warm. Pickerel came to see for himself. He arrived on a Saturday afternoon in late February, when the temperature was 8 degrees above zero, and the wind was blowing hard from the northwest. He stepped through the Karimov door and felt the difference immediately. Not in the air, which was no warmer than any stove-heated cabin, but underfoot. The floor was warm through the soles of his boots. He stood still for a moment, confused by the sensation, then looked at Togrul, who gestured toward his feet with a slight nod. Pickerel sat down on the bench by the door and pulled off his boots and his 2 pairs of socks and set his bare feet on the felt rug and did not speak for approximately 30 seconds. When he did speak, he said only, "How much?" The reaction from the broader community was the same reaction that frontier communities always had to unfamiliar techniques: curiosity mixed with suspicion. A heated floor was not a concept that any of the valley settlers had encountered. Heated floors were not part of the American building tradition. Americans heated rooms with fireplaces and stoves, and the idea of heating the floor itself, of putting the heat source under the living space rather than inside it, was foreign in a way that felt wrong to people who had been building cabins the same way for 3 generations. Calhoun Loomis told Pickerel that burying hot coals under a wooden floor sounded like a recipe for burning the house down. Pickerel pointed out that the Karimov cabin did not have a wooden floor. It had a stone floor, and that stone does not burn, but Loomis was not convinced. The idea of fire under the floor, even separated by stone, made him uneasy. Togrul did not argue with the skeptics. As with Ioannis Tsakonas and his spring capture, and Heinrich Vogt and his insulated walls, and Piotr Kovac and his hay bale foundations, Togrul let the results speak. The results spoke clearly. The Karimov family had spent the coldest winter in a decade walking barefoot on a warm floor, while every other family in the valley wore boots inside their own homes. The Karimov firewood consumption for the winter of 1889 to 90 was 4 1/4 cords, compared to the valley average of 6 to 8 cords for a stove-heated cabin of similar size. The savings of 2 to 4 cords of firewood per winter was worth $6 to $12 per year, a significant sum for a homestead family and a savings that would continue every winter for as long as the system functioned. The system had no moving parts, no mechanical components, no elements that could wear out or break. The basalt stones did not deteriorate. The clay-lined channels did not corrode. The flagstone floor did not rot. The iron firebox door was the only metal component, and Togrul could repair or replace it at his own forge. The system was, in practical terms, permanent. The first convert was Pickerel, who asked Togrul to build a heated floor in his cabin in the summer of 1890. Togrul agreed, and the two men worked together for 3 weeks in July and August, excavating the existing cabin floor, digging the channels, hauling basalt cobblestones from the riverbank, lining the channels, building the firebox and distribution chamber, laying the flagstone surface. The excavation was the hardest part. Pickerel's cabin had been occupied for 3 years, and the packed earth floor beneath the planks was hard as stone in places, requiring the pickaxe for every inch. The two men removed approximately 500 cubic feet of spoil from the cabin interior and used it to build up a berm around the foundation, just as Togrul had done with his own cabin. The stone hauling was the most labor-intensive part. Pickerel's cabin was farther from the river, nearly half a mile, and the wheelbarrow trips took twice as long as they had for the Karimov cabin. The two men hauled stones for 8 days, making 4 to 5 trips per day each, carrying approximately 150 pounds per load. Pickerel's wife and oldest son helped carry the smaller stones in canvas bags. By the end of the 8th day, they had accumulated approximately 10,000 pounds of basalt cobblestones in a pile beside the cabin, enough to fill 4 channels with some left over for repairs. The Pickerel system was slightly different from the Karimov system because Pickerel's cabin was longer and narrower, 24 by 14 feet instead of 22 by 18, and Togrul added a 4th channel to compensate for the narrower width, ensuring even heat distribution across the floor. The 4 channels were spaced 2.5 feet apart, center to center, instead of 3 feet, which meant that no point on the floor surface was more than 15 inches from a heated channel. Close enough that the heat radiated through the flagstone evenly across the entire floor with no cold spots. The Pickerel system also had a larger firebox, 2.5 feet wide instead of 2, to accommodate the slightly higher volume of heating channels and the longer path length from firebox to chimney. The distribution chamber behind the firebox had 4 damper plates instead of 3, each one controlling the flow of hot gases into its respective channel. Togrul showed Pickerel how to operate the damper system, which plates to open and which to partially close depending on the wind direction and the outdoor temperature and the time of day. On a calm, cold night, all 4 plates open equally. On a windy night with the wind from the north, close the 2 south channels to half and open the 2 north channels fully, directing more heat to the windward wall where the cold penetrated most aggressively. On a mild day, when only maintenance heat was needed, close 2 channels entirely and run the other 2 at half, using 1/4 of the normal fuel load to keep the thermal mass topped up. The total cost of the Pickerel system was $38, $20 in materials, flagstone, mortar, iron for the firebox door, and chimney materials. The basalt cobblestones were free, collected from the riverbank, and $18 in labor, 3 weeks at $6 per week. The Pickerel system performed identically to the Karimov system through the winter of 1890 to 91. Pickerel's wife, who had spent the previous winter in 3 pairs of socks, walked barefoot on the warm flagstone from November through March and told everyone she met that the heated floor had changed her life. Pickerel's firewood consumption dropped from 7 cords to 4, a savings of 3 cords, $9, and approximately 50 hours of cutting and splitting labor. His 2-year-old son, who had coughed through the previous winter from sleeping on the cold plank floor, slept the entire winter of 1890 to 91 on the warm felt-covered flagstone without a single episode. The health impact extended beyond the cough. Children who slept on warm floors slept deeper and longer than children who slept on cold floors, because the body does not relax fully when the surface beneath it is drawing heat away through conduction. A child sleeping on a plank floor at 35 degrees loses body heat through the back, the legs, and the feet continuously, and the body responds by maintaining a low level of muscular tension to generate heat, a state that prevents deep sleep and leaves the child tired and irritable in the morning. A child sleeping on a felt-covered flagstone at 70 degrees loses almost no body heat through the surface. The muscles relax completely, and the sleep is deep and restorative. Aysel noticed this with her own children in the first week, Farid and Sevda, who had tossed and shifted and curled into tight balls on the cold plank floor the previous winter, now sprawled on the warm felt with their arms and legs spread wide, relaxed and still, sleeping the way children should sleep. The chilblains that had plagued Farid's toes the previous winter did not return. Sevda's persistent cough did not return. Aysel's cracked hands healed within a month of the floor being installed, because her feet and lower legs were now warm while she worked, and her circulation was no longer stressed by the temperature differential between her upper and lower body. There was also a summer benefit that Togrul had not anticipated, but that Aysel discovered immediately. In the summer, when the Montana Valley baked under 100-degree heat, and the air inside the cabins was stifling, the stone floor remained cool. The thermal mass that held heat in winter worked in reverse in summer. The stone absorbed heat from the warm air inside the cabin and conducted it downward into the cool earth below, and the floor surface stayed at approximately 60 to 65 degrees, even when the air temperature was 90 or above. Aysel could lie on the flagstone in the afternoon heat and feel the coolness through her dress like lying on a riverbank. The children played on the cool stone floor, while the Pickerel children and the Loomis children were outside in the shade because their plank-floored cabins were too hot to stay in. The heated floor was, in summer, a cooled floor, free air conditioning powered by the same physics that provided free heating in winter, the stone simply absorbing whatever excess the environment offered and moderating the temperature in both directions. By 1895, Togrul had built heated floor systems in 6 cabins in the valley. Each system was customized to the dimensions and layout of the specific cabin, but the core engineering was identical: excavated channels lined with basalt cobblestones, a firebox with clay damper plates for zone control, flagstone surface, chimney at the far end. The Loomis system, built in 1893 after Calhoun finally overcame his fear of fire under the floor, was the most challenging of the 6 because the Loomis cabin sat on a slight slope, and the channel grade had to be adjusted to prevent hot gases from pooling at the low end and leaving the high end cold. Togrul solved this by making the channels on the uphill side slightly deeper, 14 inches instead of 12, and slightly narrower, 10 inches instead of 12, which increased the velocity of the gas flow on the uphill side and prevented pooling. It was a small adjustment, barely noticeable in the construction, but it required the kind of intuitive understanding of fluid dynamics that came from growing up in a culture where heated floors were normal and where the builders had been refining the technique for centuries. Calhoun Loomis, who had been convinced the system would burn his house down, spent the first night on his new heated floor, lying awake, listening for the sound of fire under the planks. When he woke in the morning to a warm floor and no fire, the evening's firing had gone out hours before and the basalt was still radiating heat. He told Bertie that he wished he had let Togrul build the floor 3 years earlier, and that the 3 winters of cold feet in between had been his own stubborn fault. The total cost ranged from $32 to $45, depending on the size of the cabin and the distance from the riverbank where the cobblestones were collected. In every case, the system paid for itself within 2 winters through firewood savings alone and the comfort improvement, the difference between cold floors and warm floors, between boots indoors and bare feet indoors, between children coughing from cold floor drafts and children sleeping soundly on warm stone, was impossible to quantify in dollars, but was valued by every family as the single most important improvement they had ever made to their home. The tander was a separate innovation that Togrul built only in his own cabin, because no one else in the valley baked bread in a tander, and the integration of the bread oven with the heating channels was specific to the Azerbaijani cooking tradition. In the Karimov cabin, the tander was built into the east wall beside the firebox, a cylindrical clay oven approximately 2 feet in diameter and 3 feet deep, set vertically into the wall with its opening at waist height. The base of the tander connected to the first heating channel through a clay-lined duct, so that the heat from the bread-baking fire, which burned extremely hot, 400 to 500 degrees, for 30 to 40 minutes to heat the tander walls for baking, was not wasted after the bread was done, but was directed into the floor channels to supplement the regular firebox heating. This meant that baking bread also heated the house. Every loaf of bread that Isel baked contributed heat to the floor. The tander fire alone, burning once a day for baking, provided approximately 1/3 of the floor's daily heating requirement, reducing the firebox firings from 3 to 2 on all but the coldest days. The durability of the system proved Togrul's engineering over time. By 1899, the original Karimov floor had been in operation for 10 winters without a single repair. The basalt cobblestones had not cracked, shifted, or deteriorated. The clay-lined channels had not collapsed or blocked. The flagstone surface had not heaved or settled. The iron firebox door, forged from railroad scrap, showed surface rust but was structurally sound. The mortar joints in the distribution chamber had developed 2 hairline cracks that Togrul repaired in 20 minutes with fresh clay. Total maintenance cost over 10 years. The labor of mixing and applying a handful of clay. Total system failures, 0. Total days without heating, 0. The pickerel system, built in 1890, was still operating perfectly in 1899. The Loomis system, built in 1893, after Calhoun finally overcame his fear of fire under the floor, was still operating perfectly. All 6 systems were still operating. The basalt did not wear out because stone does not wear out. The channels did not collapse because they were lined with interlocking cobblestones that distributed the weight of the floor above them across hundreds of contact points. The flagstone surface did not crack because the heat was distributed evenly, and the thermal expansion of the stone was absorbed by the sand and clay joints between the flagstones. The system was as close to permanent as anything built by human hands can be, because it was made entirely of materials that do not burn, do not rot, do not corrode, and do not decay: stone, clay, sand, and basalt. The only organic component was the felt rugs on the surface, and Isel replaced those every 3 to 4 years as they wore thin, using wool from their own sheep. Togrul died in 1912 at the age of 57. The cause was a heart attack suffered in his forge while working on a set of hinges for a neighbor's barn door. Isel found him on the floor of the forge with the hammer still in his hand and the iron cooling on the anvil. He had not been sick. He had not slowed down. He had simply stopped, the way a fire stops when the fuel is consumed. The valley buried him in the small cemetery on the east ridge overlooking the river, where he had collected the basalt stones that heated his floor and the floors of 6 other families. Pickerel spoke at the service. Calhoun Loomis spoke at the service. 4 other men whose cabins Togrul had fitted with heated floors spoke at the service. They did not talk about the floors. They talked about the man, his quiet competence, his willingness to work without being asked and without expecting gratitude, his ability to see a problem and solve it with his hands and his knowledge, and the materials that the land provided. Bertie Loomis told Isel afterward that Togrul had changed the way she thought about winter, that before the heated floor, winter was something to be endured, a season of suffering that you survived by burning enough wood and wearing enough wool, and that after the heated floor, winter was simply another season, no more uncomfortable than spring or fall, because the ground beneath her feet was warm, and the warmth came from below where it belonged. Isel continued to live in the cabin after Togrul's death. She maintained the floor system herself. There was nothing to maintain, really, but she cleaned the firebox of ash and checked the damper plates for cracks each fall, and swept the chimney once a year with a bundle of brush tied to a rope. Farid, who had grown into a blacksmith like his father and who had helped haul stones from the river as a 9-year-old boy, took over the forge and the homestead and raised his own children on the same warm floor. He repaired the iron firebox door once in 1923, replacing the original hinges that had finally rusted through after 34 years of daily use. The repair took him an afternoon at the forge. He used the same anvil his father had used. The cost of the repair was the cost of 2 hinge pins forged from scrap iron, essentially nothing. The heated floor he built in 1889 was still warming the cabin when his grandchildren were living in it in the 1940s, more than 50 years of continuous use. The basalt cobblestones that he had hauled from the riverbank were still absorbing heat from the firebox and radiating it upward through the flagstone into the felt rugs where his grandchildren's children played barefoot in the winter, warm from the ground up, heated by the same stones, in the same channels, through the same physics that had kept Togrul's mother warm in Lahıc, and her mother before her, and her mother before her, back through the centuries to the first person in the Caucasus who sat on a warm rock and thought, what if I could bring this inside? The 6 systems that Togrul built in the Bitterroot Valley operated for a combined total of approximately 300 system years before they were eventually replaced by modern forced air furnaces in the 1950s and 1960s. During those 300 system years, the total number of system failures was 0. The total maintenance cost across all 6 systems was approximately $12. The cost of occasional damper plate replacements, firebox door repairs, and chimney cleanings. The total firewood savings across all 6 systems, compared to conventional stove heating, was approximately 900 cords over their operational lifetimes, $2,700 in fuel costs that the families did not spend, and approximately 45,000 hours of cutting and splitting labor that the families did not perform. The savings were not theoretical. They were measured in warm floors and bare feet, and children who did not cough through the winter, and firewood piles that lasted until April instead of running out in February. They were measured in the hours that Isel did not spend melting snow for wash water, because the cabin was warm enough that the water barrel in the corner did not freeze. They were measured in the mornings that Pickerel's wife walked barefoot to the kitchen to start breakfast, instead of sitting on the bed for 10 minutes thawing her feet by the stove before she could stand. They were measured in the nights that Bertie Loomis slept through without waking to add wood to the fire, because the heated floor held its warmth until morning, and the cabin never dropped below 55 degrees, even on the coldest nights. Small measurements, daily measurements, the kind of measurements that do not appear in history books, but that defined the difference between a life spent fighting the cold and a life spent warm despite it. No myths, no miracles, just stone, fire, gravity, and the patience of heat that rises from below.